Hello, my name is Professor Adjovan, and this is episode 5 of the Quadratic series, and we're going to be looking at multiplying polynomials, specifically some special cases that we should know about before we get into a big topic of factoring quadratics. If you missed the last few episodes, we looked at a few different cases or a few different methods for multiplying normal polynomials, and in this one we're going to be looking at very specific special cases. A disclaimer, we're not going to be looking at where these formulas or rules come from. I'm trying to keep these videos between 10 to 15 minutes to give you quick information as you're learning this stuff on your own during quarantine. So if you think that a video explaining where this stuff comes from would be helpful, just comment it below, and if enough people comment that, I will add it to the list of videos that I'm planning on making. Let's look at the examples that we're going to be looking at in this video. So there are 3 special cases, and we have an example for each. If these problems look like the problems that you're currently working on, then this is the correct video for you. If you look at these and you're thinking that you already know how to do them, I recommend going to the next episode in the quadratic series. For everybody else, let's go ahead and jump into it. So before we even look at the examples, I want to recall some information to make sure we understand how exponents work. If we have something like x squared, what does that actually mean? Well, that means that we're taking an x and we're multiplying it by another x. If I have something in parentheses squared, that means we're taking the thing that's in the parentheses, in this case 3x, and we're multiplying it by the thing in parentheses, 3x. This is going to be important, specifically this one, for the first 2 examples that we're going to be looking at. So the first example, 5x plus 1 squared. You could absolutely rewrite this as 5x plus 1 times 5x plus 1, and then FOIL it. You could use the box method from episode 3. You could use the stacking method from episode 4, or we could use a formula because this is a special case. This is something that looks like the form a plus b squared. It is a binomial squared. So a binomial squared looks like this, a plus b times a plus b. And if we FOIL it out, if we do the box method or stacking method, however you prefer to multiply 2 binomials, you would end up with a squared plus 2ab plus b squared. So I know what the end result of a binomial squared should look like. I don't need to worry about multiplying it out in the traditional way. We can basically jump straight to the answer as soon as we identify what a and b are. So a is my first term in the binomial, 5x, and b is my second term in the binomial, 1. My formula says a squared. Well, what is 5x squared? Okay, 5x squared is not just 5x squared. It's a very common mistake that I see my students make. We need to have it in parentheses, which means the squared distributes to each of these. So 5 squared is 25, and x squared is x squared. So we would have 25x squared. The next term in my answer should be 2 times a times b. Well, what is 2 times 5x times 1? Well, 2 times 5 times 1, multiplying the coefficients, we get 10. And then multiplying the variables, well, I only have one variable, x, so we would have positive 10x. And then my final term in my answer should be b squared. Well, b is just 1. What's 1 squared? Well, it's 1. So just like that, using this formula, we end up with a final answer without actually multiplying this out. What if I have a binomial squared, but there's a minus between it? Okay, there is a plus here. What if I have a minus? Meaning, what if I have an a minus a b squared? If we rewrote this as a minus b times a minus b, and then FOILed it out or multiplied using the box method or the stacking method, we would end up with a squared minus 2ab plus b squared. So now that we have our formula following the same way that we did this in the last example, we can identify the a and identify the b, and then kind of plug it into our formula. So we have an a squared. Well, what is 2x squared? Again, it's not 2x squared. The squared distributes, so 2 squared is 4. X squared is x squared, so 4x squared. And then we have 2ab, so 2 times my a, 2x, times my b, 5. 2 times 2 is 4, times 5 is 20. And x is the only variable, so I have 20x. Now notice I said that b is 5 and not negative 5. I'm saying that because my formula says that it's minus right here. So I don't want to put a negative in there and then think I'm going to get a negative 20 and then put this negative here and make it a positive. No, no, no. We want to have a minus 20x in our answer. So I always tell my students the a and the b do not contain the sign in the middle. Specifically, the b does not contain the sign in the middle. And then finally, I have b squared. So b is 5, and 5 squared is 25. Just like that, yet again, using the formula, we get the final answer without having to multiply this out. But let's be honest, if you multiplied this out and you multiplied this previous one out, it probably wouldn't take you as long as doing this. Maybe it would take you the same length. Maybe doing this is just a little bit quicker. There is one special case, though, that is very powerful. It's when we have two binomials being multiplied and they look exactly the same. I have a 3x and a 4, a 3x and a 4, but there's a key difference that one is minus, one is plus. So if I have a minus a b times an a plus a b, and I multiply these two out, I FOIL them, I use the box, I use stacking, whichever method you prefer, you're going to end up with an interesting answer. You're going to end up with a squared plus 2ab minus 2ab minus b squared. And if you combine the like terms when you do this, these two cancel. Plus 2ab minus 2ab. So your formula for this is a squared minus b squared. As a note, because this is going to come up later, in later episodes that is, this, when you're multiplying these two things that look exactly the same but they have different signs, these are called conjugates. And this, having an a squared minus a b squared, is the difference of two squares. Okay, just some vocab, we'll call it, to prepare you for what's going to come later. Alright, so let's multiply these using the formula. This formula is very nice, and it's one of my favorites because we don't have to worry about the middle terms. We just have to identify what a is and b is, square them, and put a minus between them. So a is 3x, b is 4. So what is 3x squared, and what is 4 squared, and then we just have to put a minus between them. So 3x squared, remembering that we distribute the squared to both the constant and the variable, we get 3 squared is 9, x squared is x squared, minus 4 squared is 16. Just like that, we are at the final answer using the formula. So over the past few episodes in this quadratic series, we've looked at a number of different ways to multiply polynomials. How can we go backwards? Meaning I'm given a answer of the product of two polynomials, and I want to go backwards. That's what we're going to be discussing in the next few episodes, factoring. If you found this episode useful, consider giving it a like and consider subscribing for more math lessons. If you have a question, comment it down below and I'll do my best to get to it and answer it and help you out the best I can. Alright, thanks, and we'll see you in the next episode.